Hello and welcome to the Life on Earth podcast.
Thanks for having me.
Perhaps you can take a moment and introduce yourself to the audience.
Sure, my name is Bob, and I'm a microbe organism called Polymerus fumari, which is a species from the Archaea domain. Please call me P. fumari for short. I'm very small in size, a microbe in fact, and I live in hot water around Brothers Volcano, which is located 322 kilometers northeast of New Zealand and about 1,800 meters underwater. Humans consider me an extremophile, but in fact, I'm really a thermophile.
Are you offended if someone calls you an extremophile or a thermophile? Are you anti-cold?
No, I'm not per se. Extremophiles, aka lovers of the extreme, are living organisms that survive extreme environments of any kind, hot or cold, dry or wet. In my case, as I am a lover of the heat, I'm technically called a thermophile, lover of the heat. And my cousin, strain 121, can be called a hypothermophile, as he lives in the highest of temperatures.
Can you expand on what the word extreme means to you?
An extremophile means lover of the extreme. The extreme really comes from the human perspective. I see extreme conditions as those where the majority of species can't grow or survive. Since there are more microbes on Earth than humans, perhaps the humans live in extreme conditions, from my perspective at least. Nonetheless, as your audience is all human, we can talk from the human perspective. But for us extremophiles, it's normal to live in environments that lack oxygen or moderate temperatures. So, an extremophile, defined by humans, means a living organism that can live in environments on Earth that would kill any human. For example, high temperatures, low temperatures, highly acidic, very acidic. In fact, most life on Earth. In my case, I live in extremely heated water at around 130 degrees Celsius and with no oxygen. I won't survive in normal temperatures or in oxygen, and that's why I've had to do this interview remotely.
Really? You would die? Why is that?
It has to do with my biology, my enzymes. They have evolved over millions of years to be useful only at high temperatures. I'm also anaerobic, which means that I live without oxygen. In fact, oxygen poisons me. I am an autochemotroph, which means I create my own energy from sulfur and not oxygen, and create my own organic molecules from the carbon dioxide. Therefore, in moderate, my temperatures and enzymes stop functioning, and I stop creating energy and organic molecules. Hence, I won't last long.
Are there any extremophiles that just prefer extreme environments but could or do actually survive on what humans consider normal environments?
Well, extremophiles can actually be divided into two groups. They are extremophilic and extremotolerant. As the name suggests, extremophilic organisms like me won't survive extreme environments, but extremotolerant organisms can handle extreme conditions like high acidity, low or high temperatures, or low oxygen environments for a time, but thrive in more normal conditions. I have some bacteria cousins in the Atacama and Antarctica deserts that are tolerant of extreme conditions but could survive just as well in normal conditions. My cousins in Antarctica are psychrophiles, which means that they are lovers of the cold. They have adapted by using dormancy and sporulation to deal with the drought and flood conditions of those desert environments. So I guess some of us can survive in normal human environments.
Do you ever wonder what it would be like living on another planet or moon in our solar system? anywhere like our moon, Mars, Europa, or even Saturn?
Obviously, as we extremophiles evolved earlier on Earth than other forms of life, when conditions on Earth were similar to those conditions on other planets, like Mars, for example, you humans would be best served to look for life that looks more like me than it does you. In fact, as we extremophiles, whether lovers of the cold, lovers of the heat, can survive in a wide range of temperatures, water availability and oxygen levels suggest life may be possible on planets or moons that are much different than the conditions humans need on Earth. This makes life on other planets more possible.